I am Assistant Professor Milan Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Welcomes you in a video lecture for the introduction of the wind energy, chapter number 3 from the subject renewable energy systems, having subject code of 3710715 of the ME SAM First Electrical Engineering Department. So, flow of contents. So, first one is types of wind energy systems, comparison of performance, applications of the wind energy, site selection criteria for the wind energy system. So, first of all, what is wind power? Wind energy or wind power refers to the process of creating electricity using the wind or air flows that occur naturally in the Earth's atmosphere. Now, in modern wind turbines are used to capture kinetic energy from the wind and generate electricity. So this is the picture for the wind generator. So these are the blades connected with the generator, and due to the force of the air, natural air, blades will rotate in circular motion, and it give the centrifugal force to the generator, and due to this force this generator rotates and energy, it give energy. So this is the basic principle of working for the wind energy. Now, types of wind power. So first, utility scale wind. In this type, wind turbines that ranges in the size from 100 kilowatts to several megawatts, where the electricity is delivered to the power grid and distributed to the end user by electric utilities or power system operators. So, for the utility scale wind power, the size is from 100 kilowatt to several megawatts. Now, distributed or small wind power, single small turbines below 100 kilowatts that are used to directly power a home, farm or small business and are not connected to the grid are called distributed or small wind power system. Means the wind power system which are not connected with the grid, and it give the supply to the particular home, farm and small business, then it is called distributed or small wind system. Now, offshore wind power system. Wind turbines that are erected in large bodies of water, usually on the continental shelf, means at a seashore or in the sea. Offshore wind turbines are larger than land-based turbines and can generate more power due to the abundant quantity of the uh, plantation area. Now, advantages of the wind power system. It is renewable and not depleted with the use like fossil fuels. So, wind energy generation is eco-friendly and does not pollute the atmosphere, unlike in case of generation from the coal, oils, etc. etc. The cost of installation of the wind power plant is competitive compared to the conventional power plants. Since there is no fuel cost and low maintenance cost, the cost of energy produced in the long run is almost free. So after long time, its running cost is zero. Wind energy systems does not require fuel and its transportation is zero, because no fuel is required, so no transformation is there. In large portion of the world, wind blows for 320 days in a year, and this gives them an advantage over sunlight in direct conversion program. So out of 365 days, wind blows for the 320 days, so it is better than the solar power system. Now, another advantage is for the wind power: clean and environment friendly. Second, renewable and sustainable. It is also low maintenance. It has low running cost. Industrial and domestic installations are easy. It can increase energy security and job creation. Due to wind energy power plants, so job creation will be occur because it is required to control the power generated from the wind power system. So many engineers and other workers are required for the running the wind power plant. Now, disadvantages of the wind power system. Wind energy is available in dilute and fluctuating in nature. So wind energy is available in dilute form, means very less density and fluctuating in nature. So it may be vary with the time. It is necessary to store wind energy in some other forms during period of high wind for use later on during calm. So it is necessary to store wind energy in some other forms during period of high wind or peak wind during the time. Favorable winds are available only in few geographical locations. So for few geographical locations, the required wind speed is available. So there is a fluctuation in electrical power depending on the fluctuating wind speed, because the generated power is directly proportional to the speed of the generator, and the speed of generator is proportional to the wind speed. The capital cost is high at present. It is about rupees 3.5 crores per megawatt. So this cost is very high, 3.5 crores per megawatt during installation, but its running cost is very less. It cause negative impact like noise, bird hits, land erosion, impact on the wildlife, etc., etc. It cause negative impact like noise and bird hits, land erosion, and impact on the wildlife. So this is the major disadvantage for the wind power system. Now another disadvantages of the wind power. So fluctuation of wind is the major drawback for the wind power. So we have to provide some voltage controller for this overcome this disadvantage. Noise and pollution. Noise pollution is there due to the rotating of the large blades. Not a profitable use of land. So more land is required for the small megawatt. So threat to wildlife. It is bad impact on the wildlife. Then installation is expensive, as we discussed earlier, 3.5 crores per the megawatt. So these are the main disadvantages for the wind power system. Now applications of the wind energy. Now first application requiring mechanical power. For the mechanical power generation, first, wind pump. In remote areas, low power turbines are used for mechanical producing power for pumping water. These are also known as wind pump. So in remote areas, the wind application is used for generating the or pumping the water. So this application is known as wind pump. Now heating. A paddle wheel and other turbulent fluid systems are used to producing mechanical power into heat. The available hot water is used such as or employed for space heating. So a paddle wheel or a turbulent fluid system are used to producing mechanical power into heat by using the wind power. So and this hot water is used for another surface heating or space heating. Now sea transport. Wind turbines are installed on board to power propellers in ferries operating on short routes. So sea transport. For small route transportation in sea, we can use wind turbine and install on board to the power propeller in the ferries for the short routes. So these are the mechanical power generation using wind power. Is off-grid electrical power source. Off-grid electrical power source. Machines of low to medium power ranges up to 250 kilowatt can be used to supply power to isolated population farms, cooperative space heating and cooling, commercial refrigeration, desalination, and to other small industries. The generators may operate in stand-alone mode or may be connected a mini power grid system. So small machines in ranges from 250 kilowatt can be used to supply power from the wind energy systems for the farming purpose, home or domestic use. So it is called off-grid electric power source. Now third application is a grid connected electric power source. And in previous application, the electrical power generated from the wind energy is not connected with the grid, so that's why it is called off grid type electrical power source. Now in as grid connected electric power source, the power generated from the wind energy is connected with the grid. That's why it is called a grid connected electric power source. Now, large wind turbines generators or more than 250 kilowatt to a few megawatt capacity are used fuel supplying power to a utility grid. Wind farm consisting of large array of wind turbine generator are used for this purpose. So large wind turbines in ranges from 250 kilowatt to a few megawatt capacity are used to fuel supplying to the power to a utility grid. So in this type, the power generators more than 250 kilowatt and a few megawatt capacities are connected directly to the grid and fed to the power to the grid. Now wind farm consisting of large array of wind turbine generators are used for this purpose. So large wind farms are used for grid connected electric power generation process. Now, site selection consideration for wind energy. So, first factor for site selection of wind power system is average annual wind speed. So, the power available in wind increases rapidly with the wind speed. Therefore, the main consideration for the locating a wind power generating plant is the availability of the adequate and uniform average wind velocity through the year. So the wind velocity is the critical parameter for the wind power system. The power in the wind through a given cross-section area for a uniform wind velocity is given by Pt is equal to kV cube, kV cube, where V is the wind velocity. So we can simply say that P is directly proportional to the wind speed cube. So for therefore the wind velocity available should be in the range of 5 meter per second to 25 meter per second throughout the year. So proper working for the wind power system, it must require the wind velocity in range of 5 meter per second to the 25 meter per second throughout the year. Now second factor is location. As the building forest offer the resistance to the air movement, the wind farm are located away from the cities and the forests, and also required flat open area should be selected as the wind velocity is high in the flat open area. So location must be away from the cities and the forest, and it must be flat area for the proper utilization of the wind. Now another factor is altitude of the site. So altitude of the proposed site should be considered because higher altitude grounds experience strong wind than a lower altitude ground. We know that as increase the height from the earth, we can experience a higher wind speed. Thus, the altitude affects the electrical power output of the wind energy conversion system. Wind velocity must be measured by anemometer at several heights from the ground. The velocity of the wind increases with the height given by the relation V is directly proportional to h raised to 1 by 7. So we can say that velocity of wind is directly proportional to the height of the or altitude raised to 1 by 7. So we can increasing the velocity of speed directly increasing the height of the our wind system. So this relation is applicable for the height between 50 meter to 250 meter. So altitude also affect the air density and the power in the wind, and hence the useful wind energy system of electric power output. So the best range for the wind power system is 50 meter to 250 meter, and so the altitude of the site must be taken in consideration when we will design a wind power system. Now fourth factor is wind structure. So at the proposed site, wind should blow smooth and steady all the time. So the wind velocity curve should be flat. So it must require flat wind velocity curve for the proper site. And wind near the ground is must be turbulent and gusty. So for proper operation of the wind power system, this type of wind structure is required. Now fifth factor is local ecology. If small trees, grass, or vegetarians are present near the site, all of which destructure the wind, then the height of the tower is increases, which will increase the cost of the system. So the local ecology is also considered when the site selection for the wind energy system, because now sixth factor, nature of land and its cost. The site selected should be high load bearing capacity. The site selected should have high load bearing capacity. So due to this, we will reduce the cost of foundation, and the cost of the land should be low to reduce the initial cost. So nature of land should be high load bearing capacity, and its cost is low for the lower initial cost or lower capital cost. Now, seventh factor is transport facility. There should be transport facility for the transportation of heavy machineries, structures, materials, blades of the wind system, etc. So, it the site should have easy transportation facility for the providing this type of machineries. Now, eighth factor, nearness of site to the load centers. So the site should be located near the load to which the power is supplied. The location of site near load center reduces the cost of transmission lines, and the losses occurring in it is also reduced, because we know that as the length of the line increases, the line losses are also increases. So the site must be near the load center. Now ninth factor is most important, away from the localities. So the selected site should be away from localities so that the sound pollution caused by the wind turbine does not affect the habitant near the areas. For this purpose, main four types of sites are considered. First one is plain land sites. Plain land sites. It will utilize the plain land. Second one is hilltop site. So in this, hilltop areas are selected for the wind energy power system. Third one is seashore sites. So seashore areas are utilized for this purpose. And last one is offshore shallow water site. So this type of wind energy power plants are located inside the sea. So these 9 factors must be considered during the site selection for the wind energy power system. Now previously asked GTU questions. First, discuss the site selection criteria and the environmental aspects for the installation of the wind turbine generators asked in May 19 and also asked in January 20 for the 7 marks. So this question is important regarding our GTU examination. Give the classification of the wind energy systems. Also discuss the merits and demerits of the wind energy system. Was asked in May 19 and January 20 for the 7 marks. So for the GTU examination, we can say that this video lecture is important. So I hope you understood this lecture.